2015, a recruiting algorithm used to sift through job applicants at Amazon was found to be biased in favor of male applicants for open job roles. Then again in 2019, researchers learned that a computer model used on over 200 million patients in U.S. hospitals favored white patients over black patients in terms of predicting needs for extra medical care. In another disturbing case, a computer algorithm used widely by the U.S. court system to predict criminal recidivism and aid in criminal sentencing was found to falsely predict that black defendants were twice as likely to reoffend than white defendants. Believe it or not, these are just 3 well-known incidents of over 1,200 such incidents. Artificial intelligence and machine learning algorithms have now long been hyped and touted to be able to make complex decisions about the world around them with superhuman perception and speed. But what about when it comes to algorithms making decisions and selecting outcomes about people and their behaviors? Welcome to the IQT Podcast. On our last episode, we discussed the world of artificial intelligence assurance by exploring a recent audit that IQT Labs conducted on an open source deep learning tool called FakeFinder, which predicts whether a video is a deep fake or not. On today's episode, we dive deeper into AI bias and the bias testing portion of our audit. I'm your host, Vishal Sandasera, and joining me today, we have 3 guests. Andrea Brennen, who's the VP of Design and Visualization at IQT Labs. She's recently spent a lot of time understanding what it means to have trust in AI systems. We also have Burt, a managing partner at BNH.AI and chief legal officer at Immuta. He's also a visiting fellow at Yale Law School's Information Society Project. And we have Patrick Hall, a principal scientist also at BNH. Patrick serves as a visiting professor in the Department of Decision Sciences at the George Washington University. Andrea, Andrew, and Patrick, welcome to the show. Thank you for being here.
Thanks, Vishal.
Thank you. It's great to be here.
Glad to be here.
So let's start with a brief recap on AI assurance and the audit work that you did with FakeFinder. Andrea, I'll turn to you. Perhaps a quick refresher for our listeners, in case you're interested. We do have as mentioned earlier at the top of this podcast, an episode that covers this in greater detail, so I encourage you all to check it out. But perhaps a quick history lesson, Andrea.
Sure, absolutely. So, yeah, I would direct our listeners either to the previous podcast that we did or to one of the blog posts that we've done on this topic if you're interested in more detail. But in a nutshell, basically earlier this year, we conducted our first AI assurance audit in the labs. We looked in depth at this tool called FakeFinder, and we had to make a lot of decisions about how to approach this audit. And what we ended up doing is kind of looking at FakeFinder from 4 different perspectives. We did an ethics assessment. We looked at bias. We looked at the user experience of the FakeFinder tool, and then we did a cybersecurity audit. And so what we're going to talk about today is that bias portion of the audit. And I'll just say briefly kind of why we felt that was an important perspective to look at. So we knew that that the detector models within FakeFinder were trained on videos of human subjects. And so we wanted to understand if the tool or if the models performed differently for people who belong to different protected classes. That was a type of bias that we really wanted to kind of understand if that was in the tool. And I'll be honest, Ryan and we have followed the research in this in fairness and bias testing a little bit, but we really weren't sure kind of the best approach to take. So what we decided to do early on in the project is reach out to Andrew and Patrick, who are 2 of the smartest people I know in this area, and get some advice from them about how to proceed. And with that, I'll hand it over to them. So Andrew or Patrick, maybe if you guys could just give us an overview of how you thought about approaching the bias testing, both from a technical perspective and from a legal perspective.
Yeah, that sounds great. I'll start. So I'll start with the legal perspective, and I'll let Patrick chime in. I think as a side note, for folks who are not familiar with us and with BNH.AI, we're a boutique law firm based in Washington, D.C., uniquely composed of lawyers and data scientists. So I'm going to be representing the legal side of the house here today, and Patrick will be representing the data science side of the house. So I think from a legal perspective, we, in general, and with our clients, we start from 5 decades of precedent in what it means to test for bias, and in particular, what it means to test for impermissible bias. And in the many decades since the major anti-discrimination laws were passed in the United States, there's just a lot of materials. There's a lot of precedent for how courts and regulators and agencies seek to quantify what types of bias are impermissible. And so that's really kind of the starting point for what we do when we test these types of algorithmic decision-making systems. And we test them for bias. We start with what has been adjudicated and what we know works in the legal system. That's not to say there aren't better tests, and I'll let Patrick talk about that. There are many different types of tests, and there's a lot we could do, but we basically started with legal precedent as a foundation, and then added a few kind of additional tests. So with that, I'll pause, and I'll let Patrick fill in the technical details.
Sure, happily. I think whenever we start talking about bias testing, there's a lot of caveats, and I'll probably miss a few, but I think Andrea started out her comments by saying bias testing was just one part of this audit, and I think that's the correct mindset. And in fact, I say that bias testing is really just one part of understanding bias and unfairness, and illegal behaviors by AI systems, right? So we'll talk about the test, and they are important. But I think for the broader audience out there, considerations around experimental design or considerations around user interactions can be just as important as any sort of bias testing result. But to get into what we actually did, as Andrew introduced, we do like to use as a foundation this long precedent of legal bias testing approaches. And we like them because they're battle tested. We like them because they have somewhat clear interpretations. And we especially like them because they have thresholds. They have thresholds that you can go back into regulatory commentary or court cases and see, hey, what is the number at which this measurement becomes problematic? And I think, if you review the literature, there's a ton of really amazing and interesting work about bias testing happening now. But I'd say that threshold notion is something that's sometimes missing from the newest research. Like, we have to know, hey, if I'm measuring this, when is it bad? And so we started with a set of tests that have pretty well established notions of when a value will be bad. For the more technical people listening in, the exact tests we perform were some statistical significance testing. We used the good old adverse impact ratio and 4/5 rule. And then we got into test of the system's performance, its accuracy and error rates across different groups. And we're able to bring thresholds to bear from past legal commentary to decide when we make these measurements, are they problematic? And I'll leave it at that. And I'm sure we'll have lots of details to dive into later.
That's really interesting. Andrew, a question for you. In using previous legal precedent, in your opinion, how robust is it in a modern environment where, say, you're not necessarily attributing fault or misgivings or wrongdoings to a human, but rather a machine that was trained by a human? Are you seeing any sort of evolution in the way that the law perceives or treats, say, a machine versus a human, or is it largely that we're applying the same legal frameworks that we did to humans to machines now?
So there are lots of different questions that I could answer in there. I think from a legal standpoint, there are a couple of kind of interesting edge cases where you could talk about some kind of sci-fi notion of treating machines differently, but at the end of the day, it's always a human that is going to be at fault. And so what the law tries to do is find those humans and find those organizations responsible. There's a lot of nuance there. For example, in the fatal Uber crash where Uber hit a pedestrian, and the people who actually got held to account were I think it was the driver or the person sitting behind the wheel, even though it was on autopilot, rather than the software developers. So there's a lot interesting to say about that. But by and large, right now, that's what legal frameworks are kind of concerned with. I think one of the reasons why we start with these types of notions, even if, and we started this audit not by saying, what are specific regulators going to say about this model? Because right now, this model is not directly subject to regulatory oversight. I think the reason why we started it and why we use legal precedent as a foundation here and really everywhere is exactly what Patrick said. I think in the world of AI, just in general, things are moving so fast, and in the world of AI fairness, there's just a huge amount of uncertainty. And so what we try to do in these discussions is kind of hook or attach our analysis to something that is as grounded as possible. And I'll just say for technical folks, what we see when we get engaged in these discussions with clients and elsewhere, we see a huge amount of frustration. Everybody generally wants to do the right thing. Everybody generally has good intentions, but it is extremely easy. And I would say it's actually one of the very big dangers in approaching a subject like this. It's extremely easy to get into really, really nebulous, interesting, entirely impractical discussions about what exactly counts as fairness and what exactly counts as bias. And those are really important conversations. But for operational folks with limited time and limited resources, we find it extremely important to anchor these discussions in something that's clear and concise, and ensures there are results. So that's the thinking behind our approach. And also, like, we're a law firm, so kind of course we're going to look to the law. But I think that explains the groundwork and the foundation that we started this assessment with.
That's great. Thank you.
I'll just sort of double click on, using law as a way to avoid these almost never ending discussions about what is fair from a philosophical or mathematical standpoint. I don't think I'm qualified to answer either one of those questions. And then again, the battle tested nature of these tests, and again, the thresholds. So I think that's why we like to come from this sort of legal and regulatory standpoint.
Yeah, just to add to that, I mean, the way we looked at it from the perspective of the audit was not that this bias testing or the results or the findings that came out of it, we're not suggesting that this is the only thing you would need to know about Fake Finder. But I think the reason that we were interested in working with BNH and understanding these legal precedents is that we saw this as kind of a minimum, right? So at the very least, you want to make sure that your tool isn't violating existing laws and precedents, right? It's not to say that that's enough. Like maybe that's not enough at all. Maybe we want to go way, way beyond that. But surely we can all agree that we don't want to do things that are discriminatory in the eyes of the law, right? Like we should at least be able to use that as a baseline. So again, I just want to say that we kind of view this as like a starting point, not we don't think that we've kind of looked at every possible angle or every aspect of fairness that one might want to look at.
I think that's a great point, Andrea, and I'll just chime in here that, right, as AI or sometimes I prefer automated decision-making systems, as they become more mature, right, we just have to transition out of this mindset of like, oh, we did great on test data. Oh, we did great on the Kaggle leaderboard. Like, number one, these products have to be safe. Now, from an intelligence and military standpoint, safe may mean something very different than it does for a consumer product. But these products have to be safe. I would say that, the next baseline that we want to get to is legality, like you said. First safe, second legal, and then third real world performance, right? And so, like, I didn't even know that. I didn't even say in the top three things that we should be thinking about. I didn't say test accuracy. I didn't say Kaggle. I didn't say leaderboards, right? If we want AI to mature, we have to change the focus of our evaluations to safety, legality, and real world performance, and away from sort of test in silico performance. And so that's maybe a broader comment, but that's where my mind was going when you said we want these things to be legal. And I would certainly agree with that. And I would hope that a lot of people out there who are building their own AI systems would have this minimum bar of legality, at least in the back of their mind.
And that was another thing that we were trying to do with this audit, is explore some techniques that other teams might use as sort of a minimum set of things that you could test for, in addition to performance and predictive accuracy, which I think is kind of a common thing to test for in a lot of model development efforts. So one thing that was an interesting surprise to me, again, having not gone through this process of bias testing before, one problem that I didn't really anticipate was some of the challenges we had around not having a data set with the appropriate labels that we needed in order to do the bias testing. So I'm wondering if you guys have any advice for other teams who are interested in doing similar types of bias tests, what you would recommend to other teams who might be in a similar situation. They want to do some bias testing, but maybe they don't have the data that they need, or data with the right labels that they need to do that.
I think Andrew should jump in from sort of a process standpoint, because that's really important. And I'm happy to chime in with some of the more technical aspects.
Okay, I'm going to get ahead of my skis here, though, Patrick, and okay. I might steal some of your thunder,
That's
but sure. So it's actually, interestingly, it's one of the biggest practical problems we see over and over for teams that actually want to do this. There are so many teams and companies that practice the fairness through unawareness, and where they basically say, we're going to deprive our models of any direct, and we're going to get rid of any direct information about demographic groups, so that the model can't, in theory, can't be racist or can't be sexist or whatever. There is some kind of legal precedent to doing it if ensuring that your model is blind to those classes of data does kind of help organizations avoid any accusations that the model is engaging in any disparate treatment. But by and large, we find from a practical perspective, that approach does not work. For a bunch of reasons. There's academic research that shows it doesn't actually work. But also, if you just kind of don't want that data and you say, well, I don't even want to know, exactly what you're saying, Andrea, it becomes very difficult to actually do the testing to avoid the more kind of insidious type of bias called disparate impact. And so there are a couple things. One is, I think, just in the data collection process, to get these concerns, to really surface these concerns, we see organizations all the time raising this as an issue, like many months after data is actually collected. And so getting the data scientists who actually want to do the testing, getting them talking to, depends who they are, but the folks in charge of actually collecting the data, and making clear that this is something that they actually need, and bringing this up as a topic of discussion early, I think is just really important, like getting this on the radar as an issue. Aside from that, there are a lot of different methods for inferring demographic groups. And so one of them, the one that we tend to recommend most frequently, actually came out of the CFPB. And so it's called BISG. It actually comes from a regulator, which I think makes us and makes our clients feel more comfortable. But I think in short, if you can't get the data directly, which is what you want to try to do, there are a lot of ways of inferring demographic group status from very typical types of data, like name and address or zip code. So let me stop. I probably did get ahead of my skis, Patrick. So feel free to jump in.
Sure. So I just say again, and I think a lot of my comments are going to go back to this theme of like, we have to break out of this Kaggle game test set in silico mindset and think like, this is a product that's going to be used in the real world. And, that can have both positive and negative consequences. And so, something that I work with data scientists and our clients on is just reframing the way you think about these problems. So if you want to be serious about bias testing, you need to think about it from the very earliest days of the project. And what that means in a very basic sense is that you're going to have to extend your timelines. So, this again, another great mindset to get out of would be the go fast and break things mindset, especially for products that are going to affect humans. And so, we have to break out of this mindset and think, if this is a real product, right, it needs real time to bake, and it needs real resources, right? It needs to have groups of people who are well-resourced, who can get the data they need and have the time that they need to bake the product nicely and test it correctly. And so, that just goes against so much of what I see in the data science community, where it's just like fast and bad. Go as fast as you can, deal with whatever problems come up later. And that mindset is just not going to work for bias testing and minimizing bias and automated decision making.
Patrick,
I'll also, sorry, just this is, I think we're kind of skirting around this, but just one thing that I think is really, really important to say, and even in the the IC ethics, the guidelines, the questions we use to conduct this audit, one of the questions specifically says, what are the potential trade-offs between bias and accuracy? And I think one really, really important thing that we do and continue to kind of shout from the rooftops is I think there really is a common misconception, especially in the data science community, that there is a trade-off between bias and accuracy. And if you want the most accurate system, you're going to have to deal with bias. And I would just say that in real world systems, the two are inherently connected. If you have a system that is very accurate and performing very well for, white men, but not performing for other groups, even if they're very, very small minority groups, 0.5% of a user base might count as that. It's still a really big issue. You're not going to have as accurate. You're not going to have a model that's performing as well if it is biased. And so I think one of the things we say a lot, and we would kind of impress upon people who are listening, is to get out of this trap of thinking it's one or the other, or there has to be some trade-off. If you are doing accuracy correctly, we would say if you're thinking about performance correctly, you're also thinking about bias and testing for bias and trying to minimize it so that all different groups of people get the same levels of performance.
Yeah. And Michelle, I know you had a question, and I'm sorry to interrupt. Just to sort of take what Andrew said and fill in some technical details. Testing the performance of your model across the important segments in your data should just be a default model debugging step. Now, we can talk about whether those segments are demographic or not. When they're demographic, that gets into bias testing essentially. But, for any data scientists out there tuning in, I just think, we're all guilty of looking at these average test metrics across test data. And it's borderline meaningless, actually. We really have to dig in and test how models perform in the meaningful segments in our data, just as a baseline performance check. And so I'll leave it at that. We should transition to Vishal's question, but just wanted to add some technical flavor to Andrew's comments.
I think that makes sense. Patrick, I was going to ask you, you made mention of, in your discussion around, safety, legality, and then maybe tertiarily thinking through all the things that we are spending a lot of time thinking about right now, which is Kaggle leaderboards. One thing that strikes me as maybe being evident, and you can correct me if I'm wrong here, is it seems to be the case that in testing for and evaluating and attempting to mitigate or reduce to a reasonable extent AI bias, it's not the case that you can simply create, test your algorithm on test data, put it out into the real world, into the wild, and then leave it be and just assume that I guess I have de-biases as much as I can as of launch, and that is the end of this. It strikes me that when you mention timeline increase for the amount of time that you need to dedicate, a well-resourced team would have to dedicate to this, there certainly is a tail end of not just O&M, but literally keeping track of unanticipated biases that are showing up in the real world. Can you comment a little bit on that?
Yeah, that's a great point. It's something that has to be monitored. So I think, for very mission critical models and decision-making systems, we always urge our clients to track performance, security, and bias over time, because they can all be dynamic, right? And moreover, just another sort of, if I've reached this level of my career, I'll say pro tip for people out there listening in, correcting bias can have a lot of unintended consequences and in fact make bias worse. And so something that Andrew and I work on a lot is sort of like, what is the minimal intervention we can do here to bring some of these bias testing numbers up into an acceptable range? Because just like you said, not only is fairness dynamic and can change over the course of a model's deployment, it's pretty well known that interventions that humans take to try to make things better can often just make things worse. So I think, again, as kind of a pro tip, oftentimes it's safest just to think, what's the most minimal intervention I can do here to improve the fairness of this product. But really good points, Michelle.
Makes sense. Thank you. And Andrew, one thing that's, I think, on the top of my mind in regards to the things that you were discussing, bias, the concept of taking out bias to the extent with which we are mitigating the amount of problematic bias that exists in sort of a human cognition into machines. I'm all in agreement we should reduce that. But what comments from you on, isn't an inference, like the act of inferring something, an artificially intelligent algorithm that is designed to make a decision on something, isn't there like a certain amount of bias that you do want it to have in order for it to function, to have a certain level of performance, or actually do something that it's supposed to do?
Yeah. So, really good question. A couple actually quotes come to mind. One is the famous George Box all models phrase. All models are wrong, some are useful. And so, yes, all models are going to have bias. And in fact, the way that the ISO defines bias is something that I think is actually really helpful. So I'm actually just going to read it, which is the ISO just defines bias as the degree to which a reference value deviates from the truth. And I think it's a really interesting way of defining bias. And I don't want to take us down too deep a rabbit hole here, but I think the key takeaway from a practical perspective, I think, is to acknowledge the fact that we're dealing with the real world. All data is going to be an approximation of the real world. All models are going to be in some sense wrong in that they're an approximation of the real world. And so I think understanding that bias is unavoidable is very helpful. In some case, bias might be desirable. I think it's very helpful to kind of accept that as a starting point. And then the question becomes, how much can we reduce bias? How practical is it? To the extent that any bias is actually remaining, if that bias is harmful, is it justified? Is there any reason why we could have done additional steps that could have minimized it? These are, I think, the questions that we find to be a lot more kind of practical. And I would love to pause and get philosophical here and talk more about bias, but I'm kind of I'm gonna bite my tongue. But it's a really, really important question, and I think it's one that we've seen over and over again throws off data science teams, and can really kind of take their focus off of getting a reasonable, reduction of bias, like that's what we want them to do, and instead kind of throws them in another direction.
I think a really important corollary here is we've all been over the past 10 or 20 years, in the competing on analytics age, we've all been kind of sold this fairy tale about data. Data's, and all right, before I get into this little short rant, I think data-driven decision making is great, perhaps the best way to make a decision. But that said, data can be garbage, right? Data is often garbage. I mean, training data can be wrong. It can be biased. And if you have wrong and biased training data, then you're going to have a wrong and biased model. And so I think that's another one of those sort of like pop kind of social media type, vendor spiel things like data is amazing. Data is going to help you answer all the questions. No, you cannot assume that. Data can have all kinds of errors. It can be poisoned. It can be fake. It can be biased. And so you really have to break out of this mindset of trusting data completely, and think about what these problems in data mean for your machine learning systems and how you would act to correct them. And so, I think that one reason, Andrew said this also sort of spins data science teams into a tailspin thinking about this. And I think one reason why is just because you have to do some counter programming, right? We've all been told like Kaggle, data-driven decision-making, AI, Python, GPU, and not much of that actually makes any sense.
I would just say, sorry, okay, because I cut you off. So I would just say, and as we see kind of frontline data scientists and data science teams encounter these issues, we see all the time it's impossible for this system to be biased because we did exactly what it's doing exactly what we programmed it to do. It has the data has to be right, and we optimize for performance, and therefore it's done. It can't be biased. And there's just a tremendous amount of nuance to these issues. And so I would say accepting that there's nuance, kind of getting away from this binary things are perfect, or they're the worst, getting out of this mentality. And I think moving away from just a very kind of myopic focus on performance is, I was going to say the best way to do this, but I really would say it's the only way to do it. If you don't do it that way, it's going to be impossible to get really any results.
Yeah, I wanted to respond to an earlier comment, Andrew, that you were making, and also this idea that all models are wrong, but some are useful. I think part of what we were trying to do with this audit, in a broader sense, was just really look at what we had in front of us, right? So, I mean, maybe I think an aspirational goal would be to say, okay, we want to understand where are these models biased, and then we want to do whatever we can to mitigate or to fix that bias so that we get the best model possible. That's obviously a great goal, but I actually think this testing can be really useful, even just in raising the awareness around where the bias is, right? You can still use a model that has problems or that has blind spots as long as you know what they are. I think when the real problems come in is when you're using a model and you don't quite understand what the problems or the limitations are. And so it's giving you some results and you don't quite understand when should you trust those results and when can you not trust them, right? So I think, there's even value just in more transparency about where the bias is or in what ways is a particular model biased. And I think that's that's just something that we have to get to that step if we're going to use these tools in any kind of real world setting. Like we have to, at the very least, understand what we're dealing with.
No, totally agree. And I think, in our client interactions and my teaching and stuff, I'll see it's like, oh, we failed a 4/5 rule test. I failed the class, our product's trash. No, it's concerning if you then go and deploy it without doing anything about that. But as you said, Andrea, it just needs to evolve to be part of the workflow and be something that data scientists and their managers and their collaborators learn to handle in a professional setting.
I want to optimistically suggest that some of our listeners tuning in right now are maybe tinkering around with the Fake Finder tool. You three have had a very close and familiar and intimate look from many perspectives, and bias testing is one of the, I think, 4 perspectives that or the dimensions you analyzed. Let's dig a little deeper into what you found, specific to Fake Finder when you conducted your bias testing. Maybe, a little bit of an overview on perhaps test cases, and things you found, test methods, and what you learned.
Sure. There's tons of interesting, this was such an interesting project. One really interesting thing about testing bias in deep fakes is, do you test the face or the body? And I think we went back and forth on this and just decided to be safe and do both when we could. And so that was a really interesting twist to me, right? We essentially can have 2 people in one image, and those people could be different genders, they could be different races, and how do you account for that was an interesting challenge. In terms of the results, what we saw was that, when and this is typical of neural networks in my experience, high confidence predictions. When Fake Finder was right, its decisions were remarkably equitable. We saw good performance across different demographic groups when the system was right, which of course, and the system is usually right, but like every machine learning system, it can be wrong. And that's really when we saw the bias kick in. It just seemed like, when the system was wrong, it would be really wrong. And the results were kind of all over the place when it was wrong. And that's when we really saw the bias kick in was when, we were using label data. You do have to use test data. Even me, all high and mighty, I still have to use test data. So when we were using test data and we were able to see, Fake Finder's wrong on this instance, it was those instances where we saw more bias across the different demographic groups. When it was right, the performance and fairness characteristics looked fairly decent.
I'm curious about vulnerabilities in these and the onus of responsibility. In some cases, you're perhaps beholden to the data you have. I think we talked about this earlier. Good quality data in, good quality data or inference out, and quite the opposite is also true. Is it the responsibility, and this is a philosophical question, so feel free to just gloss over this and not get into great detail, but in the case of maybe Fake Finder specifically, how much of the responsibility is on the developers or those who are responsible for architecting and engineering the tool? And how much responsibility falls upon perhaps those who are going to, in our case, pull it down from the open source, use it, and need a balanced data set in order to actually make it work right? Is there a line? Like, should we be robust to unbalanced, unfair data sets and sort of raise a flag in the software? Or is it the case that we simply communicate, hey, look, these are the known vulnerabilities of the software. You best have these best practices in place when it comes to the data you use? Or is it some hybrid approach?
I'm going to jump in here and say that I think your baseline responsibility, which we keep talking about, is what you said. Like, look, we're publishing the system. These are the known biases. You need to be aware of them. We're working to correct them, in future releases. I think that's sort of the minimum. I think in terms of a philosophical question, we really need to get. So one, it should not just be data scientists' responsibility. I mean, I love to pick on data scientists. I in fact like this quote. The all data scientists are wrong, but some are useful. So a twist on the box quote. But it can't just be the data scientist's responsibility, right? They need support from all over the organization to get this stuff right. But I do think what's missing in a lot of data science practice is what you would find in, civil engineering or medicine, right? Where part of their education includes an ethical component, and they have these sort of ongoing licensing procedures that oftentimes include sort of updated ethical education. And so I think we just need to get to the point where data scientists can make sort of basic frontline ethical decisions and know when to raise the flag and run it up the chain and get more help. And we're just not there yet. I mean, and I don't mean that about in-q-tel. I mean that about just the broader economy.
I would add just that even the baseline minimum, and Vishal, I thought you did a good job of describing what it might be, to just the transparency, we're releasing this and here are its limitations. That is so far from the reality today. Just like getting from where we are to that level of transparency, there is such a long way to go, just to get to, I think, what we would say is the bare minimum. Certainly, I think legal standards and best practices are going to come to play here in the coming years. But I think before then, I think one of the most effective things that we see in practice is just developing standards for what you say about the model you release or the data that you're exposing and making available. So just something as simple as like standardized documentation can go a huge way in minimizing these risks and frankly, many other risks. And so that's like one of the things when organizations come and they say, we know we have this problem, we want to make a significant dent in it. We have limited time, we have limited resources. That's really like one of the first places that you can start of just standardizing the way that you disclose, model artifacts or data or whatever it might be.
Yeah.
I think
Yeah.
Model cards. Talk about model cards, Andrea.
Okay. Model cards are great. I want to make one comment, kind of along the lines of transparency. I completely agree with what Andrew is saying. I think anybody who's involved in model development across the different stages has a responsibility to be transparent about what they're doing and to disclose the limitations that they're aware of. And I just want to make a comment about that in terms of our own process. I just want to acknowledge that when we were doing this work and the bias testing specifically, we didn't have a particularly diverse team who was doing this work. And I just want to acknowledge that the labeled data set that we use is based on our team's perception of the demographics of the subjects in the videos. And so we understand the limitation, and I feel like we should own up to that and be very clear about what it is we were actually testing for. But just as an example, I think it's like in order to do this well, everybody involved at different stages of the process needs to kind of own up to the things that they're aware of that are limitations in their own.
Patrick, if you have to jump off, feel free to.
I'll stay an extra 30 seconds to say something nice, which we were really impressed by. So, and I'll try to take a pause so this is edible. On that transparency note that Andrew brought up, one thing that we were really impressed that the in-q-tel team had done was they used the model card standard, which again, I mean, to be honest, I think of model cards as sort of the minimum of model documentation, but we encounter that level of systemic documentation in like 1 or 2% of our work, right? And so Kudos to the in-q-tel team for using model cards and publishing their model cards along with.
Sorry, I have to jump back in. I can't.
Thanks.
Sorry,
and I want to be clear that was
can't.
the original Fake Finder development team. So those model cards were created by the original team at in-q-tel Labs that built Fake Finder and integrated the different defect detection models. So those were already available when Ryan and I stepped in to start this assurance audit. But it was really great to have that additional information and in a standardized format of the model cards. And it was nice to be able to just give them over to you and Andrew to help with the bias testing.
They help a lot. They really, really help a lot. And I think that as more data scientists have this experience of building real products and needing to answer really tough questions about them, these model documentation standards are going to become more prevalent. That's my hope anyway.
Great points. Andrea, Andrew, and Patrick, thank you so much for your time today. Really appreciate it. To our listeners, thank you for tuning in. If you'd like to hear more or learn more about what we discussed today in terms of bias testing or try your hand at the Fake Finder tool, I encourage you all to check out the IQT Labs GitHub repository. Additionally, you can check out the IQT.org blog, and I encourage you to check out BNH.AI for a set of resources and publications that they have released on this topic as well. Thank you again, and until next time.
This podcast was produced by Heartcast Media.